Welcome everybody to this 4-day intense seminar on applied or empirical stock flow consistent modeling. I have to say before we start that the seminar is funded by the Epoch Plus program, so the Erasmus Mundus Master on Economic Policies for the Global Transition. And I'm very glad that Gennaro Zezza has agreed to come here to Berlin. Those of you who don't know Gennaro yet, Gennaro is the expert in empirical stock flow consistent modeling. So we got the best we can get on the market to come here and teach us this method. Gennaro has been a student of Wynne Godley, right, in Cambridge. So he's worked with the founding father of this kind of method, and he's also worked with Wynne Godley with the late Wynne Godley at the Levy Economics Institute, because Gennaro is not only a professor of economics at the University of Cassino in Italy, he's also a researcher at the Levy Institute, and he runs the Levy model. So we are very glad to have him here. And well, Gennaro, maybe you introduce the schedule, how do you want to proceed, and then we take it from there. So thank you very much for coming, and I'm looking forward to this seminar.
Thank you, Eckhart. Thank you very much for inviting me. So this is the first time I try to do this course, and we'll see how it goes, which will depend on how much you already know about macroeconomics, stock flow consistent models, econometrics, national accounting. So we need to have a wide range of topics that have to be addressed. And I think the most effective way to learn how to do an empirical stock flow model is to go through each step with the students, but that will take about 6 months. So it's not something that can be done, and especially the part which is most boring and complicated is how to get the data. So I've decided to prepare the course in a way which is not to present you a model which already exists, already developed, etc., but that I built from scratch, starting December when Eckhart invited me, on a country on which I did not work before. And I will try to illustrate you every step that needs to be taken to have a model for a country. But most of the tiresome work will already be done, and hopefully we'll be able to finish by Thursday. So the idea is that we work up to 12:30, I think, in the morning. Then we have a lunch break, and then we have another 3 hours or so in the afternoon up to Wednesday, and then on Thursday we will only meet in the morning. Now, as I said, there are many different things that you need to know in order to understand everything I say. So please, if anything is not clear, just stop me and ask your questions. And in this way, I will be able to adjust my speed so that you understand everything. So also, I think we will have a short break every hour and a half or so that you don't fall asleep and my throat does not get sore. Okay. So first of all, it's not going on. Are you already familiar with stock flow models? So have you read the first chapters of Monetary Economics by Godley and Lavoie? All of you did. Okay. The other thing is I will not cover econometrics in detail because discussing co-integration techniques, server correction models will again take a long time. So I decided to restrict the part on the econometrics to the minimum, but it should be clear, hopefully, how to move from the simple equations that I will use to more complicated estimation methods. So basically, the idea of empirical stock flow consistent models for a whole country is that we want to have a model which tracks all the payments, the major payments which occur in an economy. And we can choose the level of detail that we want to achieve. And this will depend on both our research question and the availability of the data. Basically, I will go through the technicalities of what can be done with available data, but this is a standard distinction of the institutional sectors that should be available for any country which has started to produce this type of data. Now, we will go through that, but I think you already know that accounts of the institutional sectors are recommended in the Handbook of National Accounts. That is an international document published by the World Bank, the IMF, and the European Union, the Eurostat. And this is the distinction which is commonly adopted based on the function of the different sectors of the economy. So we distinguish the households and non-profit institutions serving households from the business. The business is split into financial and non-financial. We can have different type of financial institutions, etc. And you usually also have different layers of the general government. And maybe you don't know that the household sector in the data is not, as we would think, only recorded in for the fact that they supply labor to business and that they spend on consumption and save, but they also produce. They are also a productive sector. So when you look at the GDP or the value added of these institutional sectors, you will also find that the value added of the household sector is not zero, but is in some countries rather large. So this will be one first point that we will want to investigate. Because all very small businesses are classified as household businesses in the national accounts. We can have very different type of financial institutions in the data, but we will not have time or to cover everything. So the point of the stock flow consistent approach is to link all these payments respecting a number of consistency requirements. And we will go in this first class through all of them, and you should be familiar with most of them, I think. And the first one is the horizontal consistency, which implies that if a sector is making a payment, another sector is receiving the payment, and we should be able to match the sector paying to the sector is receiving. And this should be true also at the micro level. But when we aggregate for a macro model, we net out, we consolidate all payments made inside a sector. So we should be working with consolidated data where a transfer of money from one household to another has disappeared because it's not relevant for the income of households as a whole. The second principle is the vertical consistency, which implies that when, let's say, somebody buys a car, he or she is paying with some kind of financial instrument, maybe a bank deposit. So you have a recording both in the expenditure side on consumption of durable goods and on the financial account for the reduction in the balance of whomever is buying the car. So if you match these two first principles, you have what is called the quadruple entry recording, because you will have in the case of the purchase of a car, an inflow of money to the productive sector who has produced the car, an outflow of money from the households who bought the car, an increase in the bank account of the company who produced the car, and a decrease of the same amount in the banking account of those who bought the car. So we will want to have all this available, and we will see that these is not normally available and what to do in order to have a model. Then the third principle is how to go from the flows to the stocks. And basically, this implies a number of steps. The first one is that, as we will see, the saving of sectors, less their expenditure on capital account, less the investment, will form a net lending position if the sector still has some liquidity, or if a sector wants to spend more on investment than what it has saved, it will be borrowing. So it will have a net borrowing positions. So this net lending, net borrowing will imply changes in some stocks of credits and debts. And we need to link, therefore, these flows to the corresponding stocks. And in the balance sheet, this will imply, starting from the first principle of horizontal consistency, that in the balance sheet, the credits of some sectors must be matched by the debt of other sectors. And again, here we should have a consolidation principle, so that the debt of the government or credits of other public institutions should cancel out. You should be aware that this is not how data are usually presented. Usually the data for the flows are consolidated, while those on the stocks are not. And we need to keep this in mind when we build our model. And finally, our model will track the dynamics of all the major real and financial stocks. And this is done for a purpose, because we believe that these stocks are relevant for expenditure and saving decisions. So the model should imply that there is some feedback from the debt of a sector or the financial wealth of a sector to the expenditure decisions. So before we move into the detail, what about the technical things we will cover in this course? I usually work with eViews, but eViews is copyrighted and it requires a license. So Eckhart asked me to also show you how to do everything with R, which is a free software. I'm no expert on R. I know just the very basics. So I had to learn R in order to teach you this week, at least the minimum I need. But you will see that eViews is much more effective for looking at the data and playing around with the data than R. Obviously, if they charge a price, they must offer something more than a free software. So what I have done is to set up the course with eViews, and you should have had a license for installing eViews for a month on your own computer. But I've also prepared the R code for everything we will be doing with eViews, so that when we finish, you will be able to continue the work or do your own research using R. if you so prefer. And by the way, just to let you know, the e-use license is quite expensive, but students have the opportunity to get this temporary license for a semester, I think, for a very cheap price, less than €100. While there is a free license of e-use, but I don't suggest that you use it because it will not allow you to save your data and save your code, so it's completely useless. Okay. Okay, so hopefully everything this morning will be already known, but just to set things straight. Let's start with the first principle of horizontal consistency. So we want to track who is paying and who is receiving the money. And there are two ways in which we can do that. And either a social accounting matrix, which I don't know whether you've ever met a social accounting matrix, and this is the evolution of input-output matrices. So in input-output, we record the payments made by an industry to the other industries or to the workers in a column of a table. So you'd have the household column, you would have all the payments made by the household sector, and in the rows you have all the sectors who are, or the industries who are receiving the money, so that each cell gets the amount of money paid from one industry or one sector to another. The other approach that has become more popular with StockFlow consistent modelers is a transaction matrix. And in the transaction matrix, you have the sectors in the columns, and in the rows, you list each type of payment that is made in the economy, both for real markets and financial markets. And you must have, to respect the first principle, that the sum of each row is equal to 0. In here, you also, the same principle applies, but it means that the sum of the elements in each row should be the same as the sum of the elements in each column. And this is achieved by having a column for the capital account and the row for the capital account. So in the column for the capital account, you would record the payments made for purchasing real assets for investment. In the row of the capital account, you would have the discrepancy between the income and the expenditure, so the saving, and the accounting consistency would imply that if you have demand equal to the supply, then you also have that saving equal to investment, as is always the case in the accounting concept of equilibrium. So let's see whether it's easy to have a transaction matrix when working with real data. So, as I said, these are presented in this manual, the System of National Accounts, and European countries also have a slightly more recent set of accounts, which is basically the same. I've given here the links to the manuals in case you're interested to go through them. There are hundreds of pages of technicalities, so I don't recommend to read them all, but if you have some doubt on how something is measured, the answer will be in those manuals. And these manuals suggest a structure of the data for the NIPA, which is National Income and Product Accounts. So use this acronym, which is the United States acronym. And basically they follow a structure which has its own logic. So you record the value of what is being produced. Sometimes they also distinguish between gross production and value added, where the difference is given by the intermediate products. Now, value added will be made by wages, profits, which are called gross operating surplus, and net indirect taxes. And these are distributed to institutional sectors. So these are what is here is called income from production, and it becomes primary income with the addition of income from financial assets. Then you take into account transfers, taxes, etc., and you get to the measurement of the disposable income of each sector. You subtract the current expenditure to get the measurement of saving. You subtract expenditure on capital account and other capital transfers to get to the measurement of net lending. So I think it's useful to look at the data, and here I have a link to 2 countries. So I sent to Alessandro all the files I'm using. So you should have access to this spreadsheet and to others. Can you read it? Yeah. Okay. So this is just to show you the how to go from the simplification in my slide to the accounts of the United States. And as I said, you start from gross value added. Gross value added is not negligible for the household sector. Actually, this is $2 trillion which have been produced by small households in the United States. This is distributed to workers, to the government on net indirect taxes, and the operating surplus is what we would call profits. You should be aware that usually in the operating surplus of the country, you also have this category called mixed income. And this may be a little misleading, especially if you are looking at a developing country, because mixed income is the income of these self-employed. So if you're selling bananas on a street in Ecuador, your estimated income goes into this mixed income, which is part of gross operating surplus. So if you want to have an idea of income distribution, it's not just wages and profits, wages and operating surplus, but this mixed income can play a very relevant role, especially in developing countries. Then, as I said, to the wages and profits, to get the measurement of income, you add the income from assets, interest, and obviously dividends for the household sector, and you will have the payments in dividends from the business sector. Now, what I wanted to put your attention on is that here we have how much the American households got from interest payments, and we don't know who paid this interest. So this can be interest on government bonds, can be interest on bank deposits, can be interest on foreign assets. There is no payer-payee matching, and therefore what we know from the data usually is only the total amount that the sector has received and the total amount that the sector has paid, but there is no matching between who paid and who received. So we will have to do that later. The other thing which is not normally known, and I don't think I'll discuss it later, is that interest in national accounts are becoming a messy story, because when we read interest, we think it's the money that, let's say, the banks have paid to whomever owns a bank deposit, and the interest paid by households is the interest they pay on their mortgage. It's not so straightforward, because since national accounts follow the mainstream logic of economics, the mainstream logic of banking suggests that banks are intermediaries. So that in an imaginary world where we have perfect information, there's no risk, I am saving some money and I know who wants to borrow my money. There's no risk in lending, so I don't need a bank. I will find immediately with no cost whoever wants to borrow, and we would make a deal at the market price, the interest rate, and the lending, borrowing will take place. So the mainstream says, since we do have risk and we do have information costs, then banks are there in order to facilitate the exchange. And therefore, they are creating value to their customers. So this is the reason why banks can charge a higher rate on their loans than the rate they pay on their deposits. So we should consider at least part of this difference as the value added provided by the banking sector to the community. So what you have in the national accounts is sometimes, but not always, a measure which works in this way. If, let's say, the banks lend at 10% and the banks borrow on their deposits at 5%, then these people say, okay, then this means that the interest rate which would prevail in an imaginary world is somewhere in between. Let's say it's 7%. So we compute the interest paid and received at this imaginary 7% rate, and the difference between the payments at 7% and the actual payments will be the value added of the banks. So it will be what the banks have produced as a service to the households or as a service to the business. Okay, so it will not be recorded as interest payment as a form of rent, but as income from production. So you should be aware of this when looking at the data. Now, most countries are still presenting the interest payments as they are, together with these fictitious interest payments. Yes.
So could you repeat the interest rates that in your example? Do they come from data, or do they assume something, or was it just an example?
They actually take an average of the lending and borrowing interest rate. Yeah. So there is also some young PhD graduate from the New School who wrote this book saying, if this is all rubbish and actually the financial sector is not creating value, it's destroying value for the economy. And if we take out this from national accounts, we have a much better measure of the value of production, which is explaining unemployment much better, but we are not going to cover this as well. Anyway, now going through the other part of the accounts, we have the determinants of disposable income, and mainly taxes, social benefits, social contributions. They will also change according to the national characteristics of the institution. Some countries have public pension systems, other countries have not. And you get to disposable income. Subtract consumption to get net saving, and then you have the capital account where the expenditure on investment is recorded as long as with consumption of fixed capital, and also the net transfers on capital account. Now, net transfers on capital account are things you never see mentioned in textbooks. But when you look at actual countries, especially at countries which are in trouble, they are very revealing, because a transfer on capital account occurs when, let's say, the government wants to save a bank. So the government buys financial assets of this bank, which have a market value, let's say, of 1 million, by paying the bank 5 million. So it transfers 4 million in an overestimated value of these assets. Okay. So if you go to look at the accounts of Greece, which is a country for which we have a model, you will see that whenever the foreign institutions saved Greece, they made a transfer on capital account. The Greek government took this money and saved the banks with a transfer of capital account. So you learn something which is not so clear from the accounts of spending, of current spending and taxation. So as I was saying, subtracting investment, you get to net lending. And net lending is also the difference between the net acquisition of assets less the net acquisition of liabilities. Now, why net acquisition of assets? Because in each period you may buy additional financial assets, but you could also sell financial assets you already owned. So this should record the difference between purchases and sales. And the detail used here is standard, is what the manuals I mentioned before are recommending. So all countries are using the same type of distinction of financial assets. You have currency and deposits. And this is usually unfortunate for us because we want to know usually the money created by the central bank separately from the bank deposits. Okay, so you do not have this information usually in these accounts because they are merged in this category. Then you have debt securities, loans, equities, and we'll go back to this later on. And you also have the net change in the liabilities in the debt with the same type of structures. Then you also have other information which are important when modeling a real country. And some of them have been introduced relatively recently in the last, let's say, 10, 15 years. And one is the disaster losses, which try to fill a gap in the definition of GDP and the wealth of a country, because as you obviously know, if an earthquake comes and destroys a city, there is no recording of this in GDP, or there was no recording of this in GDP, but when you rebuild, then the investment is recorded in GDP. So you had this craziness that a country hit by a hurricane would not see its GDP falling, but would see its GDP increasing in the following years. Now, with these disaster losses, they're trying to match, to at least to introduce these estimates in the accounts. Then we have the revaluation account that I will discuss extensively later. And this is basically the increase in the value of assets, which is due to changes, or the increase or decrease, which is due to the changes in the market price. So these data are reasonably recent. You can see that the United States has gone back to possibly a housing bubble. Why? Because this revaluation account real estate is telling us that the American households recorded $3 trillion increase in the value of their homes due to an increase in the house prices. So this is not due to building of new houses, just to the increase in the price. So if you cumulate these are flows, so they can be cumulated, you can see that in the last 5 years, they got almost up to $7 trillion more in the value of their homes. Now, we will discuss later whether this is real wealth or just fictional wealth and what role it plays. You also have a revaluation on whatever as a market price. So again, here, the stock market in 2019, 2020 went well, and was another source of increase in the dollar value of financial wealth of the rentier in the United States. So in this part of the accounts, you split the net lending, net borrowing across different type of assets, and take into account these capital gains, and you accumulate this into the stocks, the end of period stocks, and this is the real estate, the real wealth of the Americans, along with the financial assets and the financial liabilities. We will go through this data again later on, but let's now go back to my slide. We can quickly look at the differences with how the Eurostat is producing the same type of data. In here you have downloaded a table for all sectors. Here, as I said before, you also have the output and the intermediate consumption before getting to the value added. And you also have all the sectors in a single table, which allow us to understand a little better who is paying who. So, as I said, the household sector is paying itself 230 billion of euro, and it's receiving 1 trillion euro from other sectors as wages paid and so on. But basically, the structure of the data of the accounts is the same because all countries are following the same type of distinction. In Eurostat, I think, yes, what they're called the flow funds, the distinction of the net lending across financial assets is reported in different tables. One thing I did not mention before, which is important for whomever wants to model these economies, is that the net lending that is estimated from the difference between saving and investment is the outcome of the surveys on how much people spend on investment, how much people save, and so on, while the net lending coming from the financial account is estimated usually by the central bank, and it's based on surveys of the financial markets, financial institutions, and so on. So as it always happens when the same concept is measured from two different sources of samples, the outcome is not the same. So you have that here, the net lending in 2020 from financial markets was 2.6 trillions, but only 2.5 some trillions from the saving less investment. And again, this discrepancy can be very large for some countries because it depends on the quality of the service that they run. I have a puzzle that my German friends never solved on what Germany does to have this discrepancy disappear. So if you look at Germany, Germany does have this discrepancy as two different measures of net borrowing, but only for the last 2 or 3 years when the data is still provisory, but then it disappears. So they must allocate this discrepancy somewhere in the accounts. I have not built a model for Germany, so I don't know the details, but you know, if you ever work on a stock flow consistent models for Germany, you will have to investigate what is this, how they have addressed this problem. Yes. We, for the Levy model for the United States, we use the NIPA data, the national accounts, but we also use flow funds data. So the procedure we adopted for the Levy model of the US is very similar to what I will present this week. Then we have other models now. We have a model for Greece. In the model for Greece, we are more close to the financial data than we do for the US, because unexpectedly, the Bank of Greece is publishing the matching between creditors and debtors. So this helped us a lot in building this model. We have a model for Italy that my son developed as his PhD thesis. And in that model, we have an even greater use of financial data. And I have a model for Ecuador, which again is similar to the model for the United States that we will discuss. So we have all this sequence of data, and this is all information we will want to use in our model. These variables that I've listed here, what I've listed are the basic accounting identities. And we will want to check how much we want to have in the model and what we can abstract from in the model. What we usually neglect is the first part, so it's the distinction between gross output and value added. But you usually always want to have the disaggregation of value added across compensation of employees, gross operating surplus, and mixed income, indirect taxes and subsidies. We will see also what else will need to be taken into account. But here, yes, I don't remember exactly what is this about. But maybe if we will look again at the table for Germany, we'll find. So the problem to be addressed is that of matching who is paying to who is receiving. And how can we proceed? So this is especially relevant for payments related to income from capital, because for wages, business pay the workers. For taxes, usually it's the government who gets the money. But interest is more complicated, especially when you have international capital mobility. So what we usually do, as we will discuss later on, is to look at the balance sheets and see who is in debt and check whether we can understand who is the creditor, and then use the structure of the credits and debts on the balance sheet to identify who must be paying to the creditor and who should be receiving. If this doesn't work, we can also use some statistical tools because, as you know, well, let me put a table on the screen. So basically, we need to estimate the cells of this table, and we know the columns total and the row totals. So there is a procedure which is called RAS, which is used in, has been developed in the input-output literature. And this procedure basically takes takes the sum of the elements of all the columns and gets the percentage which can be attributed to each column of the total. Then it splits the row total according to this percentage and check whether the numbers inside the cell match. If not, the procedure is repeated until convergence. So I don't want to discuss the details right now, but basically there are some tools that allow you to estimate who is paying and who is receiving when you only know the total amount being paid and the total amount being received by each sector. Okay, so this is enough for the horizontal consistency, and I think we will go a little quicker now through the vertical consistency because we already looked at the data for the United States on the financial accounts. So we must have a link between the saving investment and the table for the change in assets and change in liabilities, which imply the quadruple entry principle. And we simply must be sure that our model respects this quadruple entry principle by checking that the total amount of payments and the total amount of receipts are the same for each sector. We just looked at the flow of funds matrix for the United States. This is showing that if someone is lending, someone else is borrowing the same amount. And if we read the flow fund matrix by column, it must give us net lending again, and therefore help us identify the sources of funds for investment and other expenditure. Again, we have seen this already, but I think, yes, these are the same tables that I just showed you. Maybe Germany is, I didn't show you the Eurostat arrangement for flow funds, but they follow the same principle. Now, the only difference is that everything is displayed for all sectors at the same time. Let me enlarge this a bit. So here again, it's where you should try to understand who is the creditor and who is the debtor. And sometimes it's easy, sometimes it's not so easy. So for instance, in the currency and deposits of Germany, what would we expect? And the answer is not so straightforward because you have a central bank which is part of the European system of central banks. So is the banknotes in circulation in Germany, are they a liability of the German central bank or the ECB? And the idea is that the German bank is printing these banknotes, acting as a subsidiary of the ECB, but they're actually recorded, you know, the largest amount here is attributed to the German central bank and not to the ECB, which is I would say, in the rest of the word column. Currency is, again, more in the German central bank than the ECB. For other stuff, it's complicated to understand who is the debtor and who is the creditor. So let's take the long-term debt securities, and non-financial corporations are about a half of financial corporations in terms of debt. But financial corporations are obviously the largest amount of long-term debt being held, sorry. And I would expect the government in any other country to have the largest stock of long-term debt. In Italy, it is obviously the Italian government to have the largest long-term debt of any sector, but in Germany, the government only has 141 billion in liabilities, long-term liabilities. Well, actually, there is also the debt securities, which are also part of government debt. But as you can see, it's not so straightforward to understand how we want to model this. So we'll have to discuss this later when we start modeling the country I have chosen. Now, again, this is the discrepancy I was discussing a few minutes ago between the net lending from the NIPA side and from the flow fund side. And it's not negligible for the United States and other countries, but it is zero for Germany. So how do we link flows to stocks? By the number of heads which were nodding earlier, I think you already know the details about this. But basically, this end of period stock is always changing because of some flow, and this is true at constant prices or in real terms, in quantities, and also in money terms. But in money terms, the story can be complicated if we have a market price which is moving. So Godley liked the idea of the lake, and the lake as a river which is getting water out of the lake, and the river which pours water into the lake. So what Godley said to justify his approach is that when the lake is in equilibrium, then you can measure the flows coming in and the flows going out, and you can relate the stock of water into the lake to these flows. So if the outgoing flows and incoming flows are the same, the stock of water will remain the same. But if you have a shock, so the water getting into the lake is reduced, then you will see that the level of the stock will change. So what he said in his first textbook, Macroeconomics, is that irrespective of the theory of what drives these flows and stocks, we know that if in a dynamic system, the ratios of flows to stock are stable, then the system is in equilibrium. If the ratios of flows to stocks are changing, then something is happening and we should investigate. Okay. So this is the first important thing. And basically what he did in the 1990s to identify the 2001 recession was, look, we had this ratio of net financial wealth to income for the United States, which was fluctuating around some stable value. And in the last 5 years, it started to drift apart. So something must have happened to make this drift. And since this drift is implying that the private sector is getting into more and more debt, a financial crisis will be coming sooner or later. And we did the same analysis in the 2000s to predict the Great Recession. Now, if we move from the measurement in units, in constant terms, to a measurement in prices, then the price of a stock ST in the period T will give the value of the stock. So the left-hand side of the first identity, and this is equal to the current price of the previous stock, so PT times ST minus 1. So if these are houses, this is saying that the ST is the number of houses we have today at the current market price PT, and they are given by the houses we had yesterday, ST minus 1, measured at the current market price PT, plus PTFT is the value of houses being built during the year, during the transition, and this is the flow measure. Now, if you use capital letters to denote dollar values, current price values, and we add and subtract capital ST minus 1 to the right-hand side, we can rearrange the terms and have that the market value of houses ST is equal to the market value last year plus the value of houses being built during the year plus the net capital gains. The net capital gains are given by the change in the market price times the stock in real terms. But if we multiply and divide the last term by the previous market price PT minus 1, we have that the capital gains will be the last term in my last equation, and they are given by the growth rate of the market price times the dollar value of the stock in the previous period. So this is quite important to know, because in our model, we never want to have things to be too complicated. Okay, so we have just seen from the data that we have a lot of different financial assets, for instance. For some countries, net capital gains are very important. So we want to include them into the model. But how can we measure the market price if we have thousands of different bonds and equities? And one simple way is to say, okay, we have from the data the revaluation account, the last column, the last term in the equation. We have the dollar value of last period. So if we divide the capital gain, which is the last term, by the opening stock, which is capital ST minus 1, we obtain what I call P dot, the growth rate of the prices. So we obtain an implicit measure of the change in the market price of the assets, which is what we want to model net capital gains. Now, there's this discussion which can be done on whether these net capital gains matter or not, because the idea is that capital gains are a gain for someone and a loss for someone else. So if you are considering those who suffered the loss together with those who gain in the same sector, the two things should cancel out. And for the economy as a whole, they should cancel out. So this, in principle, would say that when the housing market goes up, the homeowners are better off. So you bought a house last year, you are happy. Who is losing? Well, you will not realize your gain until you sell your house, usually. So when you sell your house, which has gone up in price, someone else will be buying the house and pay a higher price. So the prospective buyer will suffer a loss. So the idea is that if everyone is forward-looking and knows how these things work, if I want to buy a house 5 years from now and I see that the market price is going up, I should be saving more in order to be able to afford the house. The homeowners knows that the price is going up, feels richer, and will save less for the same reason. So the increase in saving and the decrease in saving should cancel out if everybody knows everything. But since in the real world we don't know everything, capital gains are usually a boost to those who earn the gain without the other consequences on who will be suffering a loss. And they also play a major role in international financial markets. Then, yeah, we do not want to go into the detail of all of this, but financial institutions have also developed ways of having you realize your capital gain before you sell the house. So you can refinance your mortgage if your house has become more valuable. These are a number of tricks that American banks use to finance households to expand credit before the Great Recession. Last, we have the two remaining requirements: the stock consistency between creditors and debtors, and the stocks to flows feedbacks. Now, another point that is very important to remember is that what we are looking at in the data and in the model are end of period values of the stocks. Okay. So when you look at the, let's say, the stock of loans of non-financial companies, and we have a measure for 2020 and a measure for 2021, is the difference what companies borrowed during that year? And the answer is no, because if you know how the monetary circuit works, do you know the theory of the monetary circuit by Graziani and others? Have you ever heard of it? Yes. All of you? Good. I'm happy. Graziani was my supervisor for my undergraduate thesis. But basically, what the circuit suggests is that the circuit of production starts with finance. So firms need finance to pay wages in advance. So they borrow. Then they sell the products and they recover the liquidity and pay back the initial loan. So they remain in debt with the banks when they are unable to sell what they plan to sell. So the end of period change in the loans is not what they borrowed, but is what they were unable to pay back at the end of the period, having sold everything they managed to sell. Okay. So we tend to forget this when we do our model, and we have a data for the stock of loans, and we use it to measure borrowing, but things may be more complicated. Finally, last of my first set of slides is the stocks to flows feedbacks. Now, when we build our model, we will want to have these stocks, but we also need these stocks to have an impact somewhere in the model. Otherwise, it's just a, an exercise. And what usually happens with the theoretical stock flow models is that you have a stock in your balance sheet, but you don't link it to anything. And in the model, the stock is going nowhere without any economic rationale. This is usually happens very frequently when in your simple stock flow model, you allow the business sector to have a stock of net wealth. Okay, so it's usually we always have a stock of net wealth for the household sector, but the productive sector, the business sector, in its balance sheet will have the real capital as assets and usually equities and loans as liabilities. Okay, now either you assume that all of the capital is financed by selling equities or getting into debt. So if you assume this, then the balance sheet will imply a zero net wealth for the business sector. Okay, which makes sense because at the end this is saying that the real owners of the capital are the households. But if you introduce in the model retained profits, okay, for the business sector, and assume that the business sector is financing capital, financing investment with retained profits, then the stock of capital will no longer be equal to the sum of equities plus debt, and you will have a net stock of wealth, which is the difference between the value of your capital and the value of debt. And you have to do something with it in the model. This is at the basis of what is called Tobin's Q in some models. Now, if you just forget about this and then you go and look at the outcome of your model, we'll find that this net wealth of the business sector is either going to the sky or getting negative and nothing happens, which are two things that are not really consistent. So when we talk about stock flow consistency, it's not just a matter of accounting, but also logical consistency. Okay. Okay, I think we all deserve a first break. Okay. So another set of slides of introduction before we move to the start of building a model. And it should be clear that we have to make a number of decisions when we want to build our model, because we are obviously usually interested in getting into more and more details, but the complication, the complexity of the model increases exponentially with the level of details that we want to achieve. And sometimes things becomes intractable when the model is too complex. So complexity increases both with the number of sectors we want to discuss, or maybe the number of financial institutions we want to include, and with the number of different financial assets that we want to consider into the model. So in this week, unless we go very fast, we will stick to the simplest possible model made up of three sectors. So the private sector, which will include both the households, non-financial business, and the financial business, then the public sector and the foreign sector. So this is the model that Godley used, and actually Godley had this, was part of this so-called New Cambridge view, and the New Cambridge view had this measurement of the net wealth of the private sector as a whole, including households and business and financial businesses, that most other economists would not really understand, because standard economists would say, but you need to have the maximizing behavior of households and the maximizing behavior of firms. How can you merge the two and have an economic model? And the answer Godley gave was the one I gave you before of the lake and the rivers, that even in this simple model, you can identify trajectories which deviate from stable equilibrium. So we will start also with the private, public, and foreign sector. And the other source of complexity is the amount of financial assets we consider. So it's usually easier to have the simplest form in which we identify which debt each sector is taking and who is owning that debt. So a simple framework could have the real capital owned by the private sector, the equities, which are the sources of funds for investment, since if we have the banks included in the private sector, then the loans made by banks will be a liability for firms and an asset for banks, and they cancel out for the whole of the private sector. We will have the government, which needs finance and therefore borrows, and we will want to have a debt of the rest of the world, which is an asset of the domestic sector. But then this will change according to the country that we are studying. Actually, there are two ways in which people try to address empirical models. And one way, which I would say is a little naive, is to take a theoretical model from Godley-Lavoie and say, okay, let's get real data to apply to these models, and let's see what comes out. But sometimes this makes no sense at all. So, for instance, I worked in Ecuador and some students presented a StockFlow model taken from Godley-Lavoie, and they applied it to the economy of Ecuador. But Ecuador, is a small country with a lot of oil. It's dollarized, so has characteristics which are completely different from other countries. In addition, the government owns most of the oil companies, so the government has a large amount of assets rather than having a large amount of debt. So you simply, their model simply did not make sense because it was missing some key features of the economy. So what we suggest, what we will do here, is to have this general structure, but then to go and look at the data of the balance sheet to see which assets are relevant in that particular country. And from there, we will develop our balance sheet. And from our balance sheet, we will have the details of what we need to have on the transaction matrix. So I've chosen to use Mexico as our case exercise. And this is for a number of reasons. Why? One is that I read Spanish, so I could understand something of the statistics. I gave a seminar in UNAM some years ago, so I already had a little knowledge of the country. And Mexico is an intermediate case. It does not have very detailed data, but does have some data. So it's not like countries with no data at all, but not on the other side as Greece, where you have everything. So the first thing you need to check is whether you have the data for your balance sheet. And the other problem is that, as I implicitly told you in my previous slides, we want to separate the measurement of stocks in some constant price terms from the stocks at current values. So we also need to understand, if we have the data, how these data are measured. And sometimes, especially for developing countries, you don't have data at all. So if you don't have data for the stocks, and this is common for the stock of capital, you need to estimate them. And we can use the StockFlow consistent dynamic identities, like this one for investment, in order to estimate the stock over a period of time, starting from a benchmark value. So usually what is done for the stock of capital of an economy is to have a starting value where the stock of capital is usually 2 or 3 times GDP. And then you add net investment and you have a measurement of the stock of capital at historical costs. So without taking into account possible price changes if this capital has a market price. And actually, if you go to Eurostat and take the table for the stock of capital of the countries, and you divide this by their GDP, you will find that this is exactly what Eurostat has done. So they don't have the data, and they have estimated the data using this method. And the same can be done for the other stocks we need. And we will need a stock of net assets for the government or net debt for the government. So if GS is the government surplus that is usually published in any country, and you have a starting value for the government debt, you can evaluate the dynamics of government debt at historical costs by accumulating the deficit or subtracting the surplus, as in this identity. Here you will be missing the fluctuations due to the market price of the government bonds, obviously. And the same can be done for the international investment position of the country, which I called NFA in here, net stock of foreign assets. And this is the result of the accumulation of the current account balance in the balance of payments, starting always from a reasonable value. And then we know that in a 3-sector model, the net wealth of the private sector, the net financial wealth of the private sector, must be given by the debt of the other 2 sectors. So it will be the sum of the government net debt plus the net financial assets, which are debt of the rest of the world. So this is how you can obtain an estimate of the stock of net stock of financial assets of the private sector. Now let's look at some data for another country which we did not look at before, just to see what is most relevant in these countries. And I hope I highlighted the relevant lines. So here we have all the sectors of the economy and all the different type of assets. Yes. So you can see that in the data, most of the things are negligible or at zero, and you have to go and look for values which are more relevant. So here, for instance, the unlisted shares are apparently a large amount that should be considered. Let's go to check the equity and investment fund shares are important. Let's look at the loans, and the loans are most relevant. Actually, here for so the non-profit institutions have a large debt in loans, and the other one is that of non-financial corporations. Long-term, let's look at debt securities, which should be the main debt of the government. And this is not the case in here. The main debt in debt securities in France is that of foreigners. So these are held mainly by foreigners, while the government has debt in what is called long-term debt securities. So basically, you go to these tables and try to understand what needs to be addressed and what can be neglected. So let's look at the equities. So the equities are a liability mainly of non-financial corporations. You may want to know who is owning these equities, and actually the government has a very small stock of the total, and it's not clear what else is owning this. I don't have the household sector in here, I don't know why, but the other main holder should be the household sector. I also don't have the rest of the world. Oh, okay, this is where my simplification. Here I have all I build that table in billions, and this is the table in million of euro. So non-financial corporations have 4 trillion of liabilities in equities, and actually this will be the households and non-profit, I think. Yeah, this is households and non-profits are holding only a fraction of this. Here you also have a disaggregation, which I think can be used in order to match the creditor to the debtor for this economy. Let's look at the other country for which I prepared the table, which is Germany. So the structure is the same. I simplified the table by aggregating the data. So what you want to do, as I briefly mentioned an hour ago, is to net out the assets to the liabilities, because as I told you in this data set, well, this is saying that data are consolidated, but usually they are not consolidated. So you have the assets of banks, which are liabilities of other banks, are added, they should appear in the data. So what you usually want to do for each asset is to subtract, let's say for here, long-term debt securities, you want to subtract the assets from the liabilities or vice versa to try to identify who is the creditor and who is the debtor. So once you do that, you get a simpler representation. And here, this is rather straightforward. Liquidity is mainly held by households and in a much smaller amount as bank reserves. So you may decide after looking at this table that you can safely neglect the demand for liquidity by the government and concentrate on the demand for liquidity, also the demand for liquidity of non-financial corporations, and focus on the demand for liquidity by the household sector. For debt securities, the larger debtor is the government, and the major owners is the financial corporations along with the central bank. And again, the household sector is not so relevant. But then you should also consider that the households in the last 20 years have slowly moved from the safe assets of government bonds to other assets issued by financial institutions like insurance funds, pension funds, and so on. And these pension funds, investment funds, do purchase government bonds. So basically, there is a sort of intermediation, and the household sector is, at least for Italy, is buying roughly the same amount of government bonds it did 20 years ago, but it's doing this through pension funds, through investment funds, through insurance funds. So if you don't want to have all these details into your model, it's perfectly convenient to say, instead of having these insurance funds in my balance sheet for the household, since the insurance funds are holding a lot of the debt securities issued by the government, I will merge the financial corporations and the household sector, and I will find that one of the major owners of government debt is still the private sector, the household sector. And you simplify the model in this way. And here you also have some other important information. So for the equities issued, you have that the largest, the sector with the largest value in the liabilities is the foreign sector for Germany. So the German household sector are owning a lot of foreign companies, more than they own domestic companies through equities. And also the government has a large stake in the equity market. So again, here the standard simple textbook approach that the domestic firms issue equities to finance investment and they're bought by households only may not be appropriate because the government has an active role. And you also need to consider foreign direct investment that Germany makes abroad. Okay, so looking at this table, you have some guidance on what should be in your model and what can be neglected in the model. Again, loans here are quite important, and they are mainly through the domestic financial corporations and households for mortgages and business. So if we have only 3 sectors, do we need to drop this from view? And the answer is not necessarily. So even if we only consider 3 sectors, we can still estimate separately an investment function and a consumption function, and include a demand for loans related to investment and possibly a demand for loans related to consumption, even if we are operating at a more aggregate level of details. And we also will go through this later this week. So unless you have other questions, we are ready to start with our own exercise. Which, as I said, is related to Mexico. Yes.
Why for the US or Galway, in the traditional law, you only have these three sectors, because you have data on the household sector, you have data on the group sector. So why is it that you didn't model this separately? Because consolidation is a lot of information. And even with your explanation now, I get, of course, yes, we need to, we should not consolidate in a non-sensible way, but still, if you have the data, why is it that you work with this three-sector model, not with four-sector model, which has far more telling something about the relationship between within the private sector, so between the household fund, just household, way that we have our introductory tax. So all is granted, we have some more information. If you have the data, why are you not doing it? I understand that you're not doing it. Data, so then you have to consolidate with what is
yeah.
For, and what exactly means neglecting in what you just said? Means neglecting, I mean, you still need the value in these cells because it has to add up at the end of the day.
This is an excellent question. And as far as Godley is concerned, he started this approach in the late 70s and in the 80s. And at that time, you didn't have these personal computers so easily available. You did not have flow funds published or balance sheet published. So you had a considerable problem with the data. So the first part of the answer is that at that time, you didn't have enough data to build more complicated models. But I think the most relevant answer is that Godley was very much interested in current account imbalances. And he actually wrote, when he was in Cambridge in the United Kingdom, he wrote a lot on Britain, and Britain did have a current account deficit problem, and it needed to set the track for the exchange rate of the pound in the right direction. So the novelty of, one of the novelties of the new Cambridge approach was on how to reconcile targets and instruments, having the current account balance on the one hand and growth and unemployment on the other. So how to use fiscal policy and exchange rate policy to achieve full employment with a balanced current account. Then he moved to Denmark. I was with him in Denmark, and also Denmark had a current account problem, and we had a model for Denmark which worked pretty well. Then he moved to the United States in beginning of 1990s, and the United States also in that period started to have a persistent current account deficit. And a little later also a deficit in the net lending of the private sector as a whole. So for his purposes, having three sectors was enough to have a very simple story to tell, which provided a good answer and a good tool to have policy. Now, we developed the same model for Greece. And again, Greece did not really have a government deficit problem, but a current account problem, because when Greece entered the euro and could not devalue the drachma, they started to accumulate a private debt with foreigners, which was as large as the public debt with foreigners. And they were both the causes of the Greek implosion. And therefore, also, we have a 3-sector models for Greece, which worked pretty well because the research question we wanted to address was related to the current account stability against the fiscal policy and the possibility of getting to full employment. Now, now we have more data, and it's true, we can build more complex models. So we did that for Italy. So you have some advantages in building a more complex models, in that you can track more things, but you also have a rapidly increasing number of problems to solve. So for instance, when you move from a 3-sector models to a model which separates households, business, and the financial institutions and the central bank, so this is what the level of detail we would like to have for a complete discussion of the economy, then you need to model the portfolio of these institutions. And this is really a pain, because in the Godley-Lavoie textbook, in the Godley approach, in theoretical models, they use the Tobin approach, which is pretty straightforward. So the share of each asset in your portfolio will change with the relative rates of return of the assets, which makes perfect sense. So if the stock market goes up relative to interest rate on bonds, you will want to buy a little more assets, a little less bonds. Now, when you go and look at the data, it's very hard to find any evidence of these movements, because in the real world, the financial markets have this as an anchor, but the short-term movements are driven by speculation. So there is a large volatility in the rates of return and the composition of the balance sheets, which makes it very difficult to estimate the Tobin's approach with real data. So you end up with a problem, which is you have a more complex model, but your more complex model is not tracking the real economy as well as a simpler model. So this puzzle can be solved in different ways. One way is that, okay, it's better to have a more complicated model because it has a richer data set. So even if I'm not able to have good econometric estimates of everything, I am tracking the economy much better, at least in a descriptive way. If we want to do econometric exercises for prediction, maybe a simpler 3-sector models is better, because it's easier to get the trajectories of the relevant variables, abstracting for all this volatility that you have when you disaggregate. So this is where we stand right now. So another StockFlow model that we did not develop is that for Britain, made by Antoine Godin and others with the Bank of England. And they solved this problem by avoiding any estimates of the portfolio, but using calibration for finding the parameters in the demand for financial assets, which is a very reasonable solution, but I guess you know the difference between estimation and calibration. So in estimation, we have our function, and we estimate under the assumption that the parameters are not changing, okay? Or that the changing can be modeled by additional endogenous, by additional variables. In calibration, you allow your parameters to change, so to replicate the data. But if your parameters are changing, how can you do a prediction for the future? Because you will not know how your parameters will change tomorrow unless your calibration has found some very stable parameters, okay? So this is why we don't use calibration in the Levy models, and we use estimation. But with estimation, as I said, it's very complicated to have a 5-sector models with everything being estimated. Anyway, we can also hopefully do some exercises with this. So I think we're ready to start our exercise. And my intention is to guide you through all the steps you have to go through to build an empirical model, starting from the very beginning. So first thing we want to do is to look at what is available. And this is one of the major sources of data for Mexico. Don't know whether you read Spanish, but basically you have the system of national accounts, and this is the supply and demand statistics. And as far as we are concerned, we have the institutional sector accounts at both annual and quarterly frequency. Now, so we have enough data for our purposes. We will need to make a first decision. Will we want to use annual data or quarterly data? So this depends on our research question and or who is paying for our work. So if we want to do short-term or medium-term projections for policy purposes, you cannot use annual data, because annual data become available for the previous year around June. So before June, you are unable to use the data for 2021. Okay, you only have data for 2020. And this is too old for any politician to appreciate what you're doing. So you need to use quarterly data. If you're doing scientific work, then annual data may be okay. But most of the empirical work will use quarterly data also because you need to have a long sample for your estimates. Now, when you choose to use quarterly data, you enter another big box of problems, because quarterly data can be seasonal. So you need to check whether the data you're using are seasonally adjusted or not seasonally adjusted. Now, financial data are usually not seasonally adjusted. Are they seasonal? Well, this depends. And they may be seasonal, they may not be seasonal. It's usually loans may not be seasonal. So there's no specific quarter in which firms borrow more and quarters in which firms borrow less. But for other stuff, things can become complicated. We normally used seasonally adjusted data. And then when you have to reconcile them with financial data which are not seasonally adjusted, you will need to have some seasonal adjustment procedure run by yourself. The problem with using seasonal adjustment is that the procedure for seasonal adjustments no longer keep the consistency across aggregates. So if you have GDP, the sum of consumption, investment, net exports, and government expenditure at seasonal frequency, and in the non-seasonally adjusted data, the components match GDP, they sum up to GDP. After seasonal adjustment, they will not match GDP. There is a discrepancy, which is due to the seasonal adjustment procedure. So you need to know or understand or decide what to do with this discrepancy. So this is, again, something that we need to address. In many countries that produce the sectoral accounts for the institutional sectors, the data are not seasonally adjusted. So you will need to make a decision on that. I chose to not use seasonal adjustment for this presentation. So this is the first decision, use seasonal adjustment data or not. Second decision is, okay, if I use quarterly data, I have a longer data set. For Mexico, the data are available from 1993 to 2021. So it's almost 20 years, 18 years, times 4 is more than 60 observations. So they look like a lot, but they may not be sufficient in many cases. First of all, because you need to explain the short-term seasonal volatility with your data. So if each quarter has a different dynamic, you already need 4 parameters to estimate, to keep up with these dynamics. Then you may have structural breaks in these 20 years. You all know what structural breaks are, don't you? Okay. So we are living in interesting times because we are having a sequence of unfortunate structural breaks, one after the other. So we had the 2007-2009 Great Recession, which also hit Mexico. Then we had the COVID crisis. Now we have the Ukrainian war, which hopefully will not impact Mexico, because if it impacts Mexico, we are all dead before it gets into Mexico. So we hope it's not going there, but we already have 2 major breaks, the Great Recession plus the COVID to deal with. So this also will need to be taken into account. I looked at the description of the data made by the Mexican Statistical Institute, which in an unpredictable way is neglecting the first thing I would look at if I were interested in Mexico, which is the foreign debt and its determinants. So as I said, what we want to look at first is the balance sheet of each sectors. So I've downloaded these balance sheets, but I'm not sure that we want to go through all of these in detail because this is going to take us a lot of time. Just let's check at how they've organized the data. So they have the balance de cierre is the end of period stock, and they publish the non-financial assets, and the non-financial assets are also split among housing and other type of capital. We have the stock of inventories, and they also have the natural resources, which is something that to me is a little mysterious. I worked with the government of Ecuador last year, and they also have this measurement of the natural resources. So I asked them, but what do you have these measures for? Because on the one hand, we could say, okay, let's have a better measurement of the wealth of our country, and we include the Amazon forest as part of our wealth. So if a company comes and cuts out the trees and the Amazon forest disappears, our wealth is reduced, and we set a policy target that we want to keep the Amazon forest. But I'm suspicious that the reason why they have these statistics is because they may plan to sell these resources on the market. So what they obviously get in here is that the government, this is the household sector, the government will own a lot of resources. They are on the balance sheet of the government. So the government can say, okay, I have $1 trillion in debt, but I have $4 trillion worth of forests and lakes and biodiversity that I can sell to a multinational. So my debt is sustainable. So if this is the case, I'm not sure that this is a good sign. Again, here they have the same type of structure that we have seen for European countries, only it is all in Spanish. So we're not going to go through the details of the balance sheet of each sector, but you can do that. Maybe we could look at the central bank to see mainly the liabilities of the central bank. May be interesting if they include liabilities with the rest of the world. And obviously, the major liability is in the currency. They don't really have much less elsewhere. So basically, I guess that this will be the short-term liabilities in short-term assets, which are liabilities of foreigners. It's not entirely clear who is lending to the central bank. Well, I have to go to the balance sheet of the rest of the world to identify whether these 200 billion are the assets of a foreign institution, as I would expect. Okay, so we can look at the balance sheet of all of these sectors. And as I said, it's a good practice to consolidate, so subtract the liabilities from the assets. I have taken a summary table, which is very complicated, which will be the main base of our data set. And these sorry, I thought I had it in my computer, but I've downloaded it again from Mexico. Now, this table is exactly the same as the one we have seen for the European countries. It starts from the production side with the imports and exports of the country, of which sectors. Then these are the purchases, the exports, then the production, the gross production of all sectors. Now, you can see that there are 6,370 rows in this table. So it's a very complete data set, but you can understand that this is quite a pain to load this data into your software and match the data to the variables you want to use. So as I told you earlier this morning, this makes up 80% of the work you need to do to build the model. You know, I want to have a model. I find the data. Now I have to match the data to my model variables, and this is complicated. So the other complication is that most softwares do not like this frame of the data, this framework. Most software want the variables to be in columns, and here you have rows. They don't want to have breaks between your columns or your rows, and here we have plenty of empty rows. So what I've done is summarized in my slide. So I want to get rid of all of these breaks, and I want to transpose my matrix in columns. By the way, if you want, you can also download the file and repeat this process yourself on your own computer. I know for experience, I'm going usually too quick for students to follow what I'm doing. Anyway, so what can we do? First thing we can do is to have an identifier for my rows. So I can add a column, I can press Control+ and insert a whole column. And then I can use, I'm sorry, my Excel is in Italian, but it's should be easy to understand the English part. So I can use the row number function, which in Italian is, should be, is this one. So this will give me 7 for row number 7. And I can copy this to the bottom. I don't know whether you know how to use quickly the keyboard in a spreadsheet, because this is something that my students don't know. So you can use control arrows to move quickly and control shift arrow to fill quickly a column. Now, I will my identifiers, but I want this also to look like variable names. So let me add another column. And here I can use another function which adds v for variable. And then I want to add the number of the row to v, so that this will become v7, v8, v9, and so on. And you need to use the function text, which translates a number into text with a given format. And I can use the format with 4 zeros to have the numbers presented with 4 leading zeros, so that my variables will be also in alphabetical order. So I can now paste this result for all of my rows below. Finally, I want to fix these results rather than leaving them as a formula. So I can copy the whole column and use paste special to paste only values. Now this is not going to change anymore. I can delete this column, which I no longer need. And now I can sort my table in such a way that all the empty rows are listed at the top or at the bottom, and I can delete them safely. So I have to highlight all of my table, and then I can use sort, personalized sort without headings, sort by column B. And now I have all the empty rows at the bottom. So I just highlight the empty rows and I use delete rows to delete them. Now I select all of my data again and I sort using the first column. And since my first column has been created to be sorted alphabetically, it will give me back this same sequence I had before. And finally, I can transpose this matrix into another sheet that we could call data. In which we have everything in columns. So well, maybe the easiest way is to select everything and then use copy, Control C for copy, and then paste special again. And paste special allows me to paste only values and transpose, which is the important thing, everything in here. So now the data are in columns as I wanted. There is one problem left. Anybody already knows what the problem is? I'm missing the period. So I want to have also the quarter for which these data are referring to. So I can add another column. And here I have to specify the quarter somehow. I usually use decimals for the quarters, so that I can have this simple formula that I can paste to have all the numbers up to 2021 third quarter. And here I have to provide a name for my variable. Okay, so now our data are in the format we want. We have these rows which contain information, and we may want to choose whether to use this information directly or not. In R, I don't know how to deal with this in a proper way, so I prefer to have simply the variable name and the data, and then to deal with the variable description somewhere else. So I will delete these rows, delete whole rows, so that now I only have the variable name in the first row and the data in the subsequent rows up to the third quarter of 2021. And now I'm ready to look at, to load this data in my work file. So let me already have this file, but let me save it anyway. Okay, so this is one of the preliminary operations you will want to do when you have a large data set and you need to read it into your software. Then you need to do some simplifications. So this is what I did for the balance sheet of Mexico for the second quarter of 2021. Do you want to get this table? Do we want to work out this table now together? Okay, so let's get the we can do this either from this main source or from the individual balance sheets, but let's do it from the main source. So we will need to have this, this detail. So let's go to our spreadsheet. And I'm going to create a new file. And I want to work with the balance sheet, which is at the bottom of my table. So this will take a little time. We want the balance de cierre, which is the end of period balance sheet. Variación de balance will be the flow of funds. So we are not interested. We are not interested in the stock of capital so far. So we need to start from the liabilities and assets for each of these things. So in our measure, we will want the first one, which is oro monetario. We will want the sectors to be those that we have in here, but without considering the whole of the domestic economy. So I can copy this from here and use paste special to transpose in here. I'm going to enlarge the columns. Okay, so I don't want to have the non-profit institutions separately from the households, so I will keep them together, and I have to remember to sum the values for these two sectors. So here I will have to take the assets of the households in a given period plus the assets of the non-profits and subtract the liabilities of both sectors. This is obvious for the gold, and these are the IMF funds. So maybe we can skip this, which is so straightforward. So when we move to the next one, sorry, this was the hogares. Sociedades no financieras would be, the assets are here, and the liabilities are here. The sociedades financieras, the assets are here. And these are the liabilities. The government as assets in here and liabilities in here. The households and non-profits and finally the rest of the world. Okay, now if I want to improve the readability, I can decide to divide everything by 1,000. So to have billions. Okay, so first thing we notice is that the amount of liquidity held in Mexico, which is a liability of foreigners, is rather large, is about a half of the domestic liabilities, in liquid liabilities. So this is to be expected. I guess the Mexican economy uses the US dollar almost as much as the Mexican peso. So here is the first requirement. If we want to model this type of behavior, we will need to have into the model the possibility of a foreign currency being demanded by the domestic economy. So do you really want me to continue building this table for all the assets? No. Unless you are doing that yourself, this is very boring to watch. So we can move back to my table. In my room, a couple of weeks ago, I prepared this table in this way. And here we notice, we look at the largest figures. The largest figures are for debt, títulos de deuda, are the main liability of the government. And these are held by domestic financial institutions, but also by the rest of the world. And we also notice that the non-financial corporations have a large debt, which is presumably held by foreigners. So here, these are important issues that we will want to address. But we also notice that the loans are also important, mainly for mortgages, probably because préstamos are the loans. And you can see that the household sector is much more into debt with domestic banks than the non-financial corporations. So this means that the financial corporations in Mexico prefer to borrow either on the bond market or on the stock market, given the large value of equities that they also have in their balance sheet. And again, the equities held by foreigners of Mexican companies are rather large. And households also own a large amount in pension funds and other assets issued by financial institutions. And as I said before, we can also look at what these institutions have as assets in order to simplify the model. So now in Mexico, they have 9 billion worth of public bonds. So again, there's maybe this intermediation made by pension funds in Mexico and households own pension funds, the pension funds buy government bonds. So in the end, what matters is the link between the government debt and the private sector wealth. What also is important is the foreign account. We will be looking at the three-sector model. So we want to identify the main liabilities and assets of the government and that of the rest of the world. So here we see that the rest of the world is providing dollars to Mexico. It's lending on the bond market and it's investing in Mexico with foreign direct investment. The other values are less relevant. So we can sum up the assets and liabilities of the four components of the private sector. And we end up with this simplified table in which I also dropped a number of different financial assets which are less important. And I've consolidated them into other accounts. So here what stands out is the large debt of the government and the bonds market and the large amount of equities issued by the domestic firms and owned by the rest of the world. While we have an unexpected measurement, which is that once you consolidate, once you subtract liabilities from assets, it comes out that it is the Mexican financial sector who is lending to the foreign sector. So the foreign sector has a debt in what is called préstamos, loans, as a net debt, which is an asset of the private sector, obviously of the banks, probably. So this was unexpected, but it's a simple way in which we can identify the asset we need in the model. In the model, we need a foreign asset, which is a liability for foreigners, an asset for the country. Usually what is needed are the foreign reserves. So I don't think that these 2 trillion are foreign reserves of the central bank, but in our model, they may play this role. So simplifying further, we can drop these préstamos, or basically merge these préstamos with the liquidity and the other accounts. And we end up with only 3 assets: the government debt, which is owned both by domestic institutions and foreign institutions, the equities, domestic equities owned mainly by foreigners, and the other accounts which end up with the debt of the rest of the world, which is owned mainly by the government unexpectedly. And this is because of the large amount of liquid assets in the balance sheet of the government. So this is the structure that the data suggests for the balance sheet of our model. And this is where we will start from. And we can start providing variables, variable names to the data that we have chosen. So we will have, actually, I will want to now and then change something. And I discovered that F is a reserved word in R, so I cannot use it as a variable name. And I switch to FL. So in our balance sheet, we will need to have a stock of wealth of the private sector, a stock of wealth of the government, which will probably be negative, will be a stock of debt, and a stock of wealth of the rest of the world, which again, if it's positive, implies a net borrowing position for Mexico. We will need to decide whether some of these variables like EG are relevant, e.g. the equities held by the government are a very small fraction of the less than 10% of the overall stock of equities, so we may choose to neglect them in our model. The other important thing to consider is that we have done this exercise on the basis of the recent balance sheets. But we will go back to 1993. And what if the balance sheet has changed very much in this period? So once we have done our analysis, we should also look at the previous years and check whether the structure of the data that we have chosen and the structure of our model balance sheet is still relevant also for previous period. Now, for instance, for Greece before 2010 had a large amount of public debt owned by foreign banks. Now, when the crisis came, 2011, what the European Union did was to give a lot of money, to lend a lot of money to the Greek government. The Greek government gave this money to the Greek banks, and the Greek banks had to buy back the government debt from foreign banks. So it was an operation that saved German and French banks, which were exposed with the Greek government, with the money coming to save Greece, which went elsewhere. And if you look at the balance sheet of Greece before 2010, the Greek government had debt mainly in the bond market. After 2010, the debt was only on foreign loans made by the ECB and the whatever is called the saving, the IMF was a small portion, but the other one was the infamous institution created. Yes, the EMS, the European Stability Mechanism, the ESM. Yeah, that with the ESM. Okay, so this is our suggestion for the balance sheet of our model. And then we need to know if we have data that are coherent with this balance sheet. So for the property income, we need to know whether we have the data for payment of interest on these bonds and for payment of dividends on the equities, and for other interest payments or dividends coming from abroad. So we need to look at the flows, and I think that this table is somewhat simplified version of the big table that we are using. And here in the income from capital, we verify that we have everything we need. So it is true that for Mexico, these are the recursos, are the money going for interest payments to the rest of the world. This is what the rest of the world is paying to the domestic institution in Mexico for interest. You have dividends, and you also have something which is not so present in other countries, which is this rent that the government mainly get on land. So this is another stock that we have not considered, but that will be relevant for Mexico. Okay, so we are reassured that we have the data for whatever we want to model at this level of detail, and we can start building our model transaction matrix. I think you already know a transaction matrix, do you? You know how to build a transaction matrix. So basically, this is quite straightforward. We have, I always prefer to have a separate column for production, but just make you notice the differences with other people who do this stuff. I don't like to have production in the as income and expenditure of the non-financial corporations, but as a separate account. Now, gross value added is all distributed to the private sector, and this includes both wages and the profits. Net indirect taxes go to the government, and we have data for all of this. Then the next part of our transaction matrix will imply payments on capital, so the interest on bonds. And here the theoretical values, the variables are taken from my balance sheet. So this RBP is the interest the private sector gets on its government bonds. RBW is what the foreign sector gets on the government bonds it owns, and so on. But we don't have this data. We need to estimate them. They are not present in the table that I've shown you. In the table I've shown you, when we go to the interest, okay, the interest here are the total expenditure. So the government is spending 81 billion pesos and is getting 9 billion pesos, but we don't know who the government is paying this money and who is paying the government. We will need to match this in some way, and I will show you how we go through that. From the analysis of the data that we should have done together, but that I did to save us a number of days of work, we see that the rents are mainly paid to the government, nothing goes abroad. The social contributions are paid to domestic institutions, mainly to the government, and the government is paying pension and other transfers to the private sector. Taxes are paid to the government. And last thing is, you never want to have the detail for everything. So in the end, you will have a mixed category of other net transfers. And we don't identify who is paying and who is receiving these other net transfers, but we only have to make sure that they sum to zero across the column. So summing up the data in this part, the data in these columns, we can measure the disposable income of our three sectors. We can subtract the expenditure and get to saving, and we can finally subtract investment and get to the net lending of each sector. In the model, I've decided to avoid a separate treatment of net transfers on capital account, but otherwise, this is the transaction matrix which will form the basis of our model. Okay. So this part, as I said, is the summing up of some work done on the data to identify what is available, what can be tracked, what cannot be tracked, and what we want to have. Once we have decided on the structure, we can translate the structure into code, into equations that we can solve with the software. And this is what we're going to see next, but after we have a lunch break. So I don't know whether you have questions. A number of things I have discussed briefly, such as how we measure interest payments, will be discussed in practice when we go to the code. Okay. So unless you have questions, we can take our break. And after the break, we can install eViews and start doing some practical work. So you're not only have to listen to me for 3 hours, but
maybe just a
yes.
short question for clarification. As far as I understood this, you chose this structure due to the simplification with some research question in mind, or is it a conventional way not to summarize these things? What's your
No, well, for this model was created for teaching here. So the purpose, the research question is, let's have a model which is simple enough that I can go through it in 4 days.
Okay.
And but on the other hand, I think that Mexico does have a potential problem of foreign debt that can be addressed with a simple 3-sector models, but not with a model as simple as the one I will be discussing. So my plan is I have 7 sets of slides, and we already went through 3 of them. So if we keep going at this pace, we will have time enough to build on the work I've already done. And in particular, I have not treated the income distribution between wages and profits. So given the data that we have, after we've seen all the steps to build and estimate and simulate a model, if we still have time, maybe on Thursday, we can modify the model together to include wages and profits, and try to estimate a wage equation, a price equation, and check how the model changes with these additions. Yes.
I would just have a question of clarification for the students who are online. Because I think for them the transaction matrix looks a bit different than what I have told them. Maybe you explain different, because I don't know, like, no, that's no question, but the transaction matrix they know is one in which you have public sector, film sector, and for the film sector we have preferred and capital. Now, how does that relate to what you have done in the transaction matrix? I guess that, or that some students might be confused about that.
Let's see whether they have an answer. Not sure about that. Maybe they rely on the recording. Okay. You also had a question?
Yeah, related to one of the problems that you mentioned, that is that, we are selecting here this model based on the balance sheet of 2021. What if, as you said, like in the 90s, the balance sheet look completely different? What would you do, like adding more variables?
Yeah, we would need a more complex model. Maybe we would have to add another asset that to be treated separately. So here we don't have loans. Maybe loans played a more relevant role some years ago. So if that were the case, we could have that separately. Okay, so lunch break. Do you want to install eViews now, or when we go back, when we come back from lunch? After, okay.
So how long will the lunch break? 1.5 hours? Or what?
The schedule says until 2.
It's up to you. I don't need an hour and a half for a break. So if you prefer to have a shorter break and we finish earlier, or if you shorter break and we finish later anyway, it's up to you. I'm okay for a 1 hour break.
We began at 1:30, right?
Yeah.
Would you have to key and would you lock this room or should we take our computers and out?
Is the event open? Prior.
No.
Sure, huh?
I mean, like, you can go up and have the dinner, so
Okay. And when you are going to be at lunch? So, and because I have something to do, then maybe I can see in the room. Or maybe if together we can go upstairs and leave the mensa, even if it's closed.
Well, I think I haven't brought it. So, I think we would prefer to do what we usually do.
Go to the more place.
And go across the street and have a pizza slice and sit in the sun.
Okay. Yeah, that's okay.
So that would be my suggestion. I hope there will be place for all of us. Yeah, okay.
Yeah,